Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. We've gotten most of our expressions done, so assignment statements with simple integer and string variables. We were working on predefined functions. We had a case, well, the original basic didn't have these functions for strings and substrings and so on. And the functions that were added, they added support for multiple arguments, which it only supported one before, and they added support for optional arguments. So we were doing that. And we ran across one problem with a mid function. I'm not sure it's the only problem, but we ran across this problem. We're going to track that down. But I'm hoping the bulk of today is about arrays and subscripts. I think it's probably a 2 or 3 session effort, but we'll see how it goes. So in BASIC, you can make a declaration that says dim a sub 10, and you can, when you do, that says a is an array that has slots 0 through 10. So it's a little weird to me in that sense, right? If it were 1 based and you had the actual number, that would make sense. If it was 0 based and you had up to that number, it would make sense. But they do it this way. And actually, I don't know if I knew that it was 0 based. When I started working with this, going back to the documentation and stuff and realizing it was 0 based, my recollection is it was 1 based, and most code acts that way. But maybe it's always been 0 based and I just wasn't aware. But anyway, you can dimension an array. It defaults to 10 if you just reference the array and haven't dimensioned it. And then once you've done that, you can't come back in and say, oh, it's 20 or anything like that. You get one shot. All right. You can make assignments to arrays. A sub expression, comma, expression equals value. So that's a 3-dimensional array. And you can get the value back. So x equals b of expression, comma, expression, fetching things from a 2-dimensional array. Now, to make this all work, we're going to have to define a type. So we have it commented out somewhere in our type thing, but an array, I think the core thing for it is how many dimensions it has. So in terms of the type matching, if something works on an array of, 1 dimension, we don't expect the same code to work on an array of 2 dimensions. All right, so I think we need to basically keep track of the number of dimensions. We need to keep track of the type. Is it an array of strings or an array of integer or numbers? And yeah, and then we also have this notion of name independence. Could you have X and also an array X? And I think the answer is going to be no. We want to make one name for it. Okay, so you have to choose. And then the last thing is indexing. In the original BASIC, I think you were pretty limited. I don't know how many dimensions you got, but you had such small memory, you just couldn't create that much. The Commodore 64 BASIC, kind of 20 years later than 1964, they say you can have up to 255 dimensions. Okay, now a Commodore 64 had 64K of memory, so like how many dimensions can you really have? But it's arbitrary. Okay, and so rather than map, like we have to turn these into real Swift arrays at some point to interpret them, and I don't want to like try and define, oh, here's the 1-dimensional array, here's the 2-dimensional array, here's the 3-dimensional array, the 4-dimensional array, and so on. So we're going to work it out so that we'll work out the formulas that let you linearize the array yourself. Okay, so you multiply row by column width and add the column index kind of thing. And we'll generalize that to multiple dimensions. All right, and then the picture we've seen 10 times out of 20 sessions. The interpreters resemble compilers, so we have to worry about the program text coming in and then lexical analysis. Well, the only thing arrays bring in is the keyword dim, the left and right parentheses, which we already parse, or lex, and commas, which we added last time to support multi-argument functions. So I don't think we have to do any lexical analysis. We'll make sure dim is there, but that's about it. So no new tokens. The parsing is a little different. We have to be prepared for an array, the array stuff. It looks kind of like the function stuff, which we've done before. And then there's some more semantics that we're going to apply in there. Okay, and then finally interpretation. That's all new, so we'll have to do that from scratch. But let's go back, put our hat on from yesterday and finish up these multi-argument functions. All right. We were failing this one. Excuse me. So we have the mid function. It takes 3 arguments, but if you leave off the last one, it defaults to the length of the string. So if we're taking the middle element starting with 2, which is B, because they number from 1 here in the strings, and we don't specify, then we want the whole rest of the string. Okay. And then this one, we're just checking that if you do that for an empty string, you're just not going to get anything. No range errors or anything. All right, so we'll run this. I've got a breakpoint set. I think I know what's going on. Okay. I didn't end up being late, but I had a class at 8 this morning here. It's 9 now. It was a flat footing kind of dance, and also called freestyle American clogging. And I don't think I danced more than half of the session, but it's just like I'm quite winded, out of shape on that one. Okay, we're still starting up. Yeah, so this thing, we come into the mid function, we peel out the first argument, which should be a string, and we type checked it earlier, so it will be a string. And then we peel out the second argument, the starting point in the string. And then the third argument, we're going to default it to string.count. But if the third argument, number 2, is there and it's not undefined, then we're going to read that argument and get that. Okay. Okay, so let's step over and over. So let's look at these. Print string should be ABCDE. Print start should be 2, I think, from our test. And then let's look at argument sub 3. Whoops. Argument sub 2. Okay, it's an undefined. So that was in our test. We didn't specify it, so the syntax stuff put the undefined one in. It knows it had to have 3, so it filled in the last one. Okay, so we'll step over. So let's see what length is for now. It's defaulting to 5, the length of the string. Okay, argument sub 2, undefined. Okay, now this is what I'm suspicious about. We should only do this if it's not undefined. Well, it is undefined, right? So something went wrong here. Let's see. Can I drag this back? Is it too late? Move the instruction pointer. Okay, let's try a step into. Nope. Okay, let's run it again. But it seems like our not equal did not work, right? Because it was equal to undefined, so it should not do this. All right. Okay, we're starting over. I think. Stop. Start over. Well, I don't want a breakpoint. I want to run the test. Okay, there we go. Okay, I took my breakpoint off my wrong thing. Go. Let's break here. There we go. Okay, now I'm going to step into. Did that not? S float. No. Okay. Let's see. Yeah, this is what I think is going wrong. we said it was equatable. We gave it a static function. If it was numbers, we compare them. If it's string, we compare them. Otherwise, we said false. I don't think that's right. I think the undefined, well, if they don't match, it should be false. Is that working? Is that the thing I think is going on? Maybe something else is going on. I thought a not equal called your equals function. Okay, so we have an undefined. Oh yeah. I think that's what's going on. So let's see back here. We have argument 2 is undefined, and we're saying not equal undefined. So we come in here and we say, is it equal? We say, no, it's not equal. So it says, oh, you're not equal undefined? Okay, then let's do this. But we have a missing case here. Undefined, undefined. Should be true. Okay, if they're both undefined. And what that tells me is my value type has grown. Well, okay. Maybe what it tells me is I should be explicit. If well, yeah, let's be explicit. If we have predefined and predefined, or user defined, well, let's say we don't know how to compare functions. We just assume they're not equal. Is that gonna, do I have to put value has no member predefined? Oops. Oh, function and user function. I may have to put empties in there. I don't know. I think I don't need to. Okay, so if it's user functions, comparing two functions or two user functions, false. So even if they could be the same, we just don't know. Yeah. Okay. But this is the case I think it's showing up. All right, let's run this again. We'll turn off the breakpoint, continue. Oh, okay. Turn on the breakpoint. Well, let's see what the result was. DE. Interesting. All right, let's run again. I think maybe we're testing the actual function now. So let's print argument sub2. Okay, we'll step over. It should skip it. Yep. All right, now print string, print start, print length 5. Okay, and the length is longer than is acceptable, but that's okay. So let's step in. Now we're in our mid-dollar function. Why it couldn't just take the one over there? I don't know. Okay, so string start length. Okay, so let's print count. Well, we can see it on the left. Okay, count is 0. Wait, count is 5. Okay, start should be 1. Have I messed up the formula here? Apparently. I'm going to take the right elements. Count minus start. Start is 2. I think that's plus 1. All right. Count is 5. Start is 2. Count minus start is 3 plus 1 is 4. That's what we expect to pull. Okay, because we're trying to skip over the start characters. It's really kind of count minus parentheses start minus 1, I think. Okay. Let's try again. Maybe I should just step through the rest of it though. Okay, we'll continue to there. Okay. Step over. Start is 4. Start's a bad name, isn't it? Especially since I've already used it. Oh man. Let's call this like keep on right, or right string, rightmost count. Right count. I don't think that's bad. Prefix of length is 5. The first 5 characters of that. Okay. I don't think that's going to affect it. Okay. Right string is BCDE. That's good. The length is 5. The prefix should be good. Okay. And it's funny. Something I saw said, oh, we tell you the return value as we're coming back. And I just have never seen it. Okay. Let's just continue. And continue. Okay. Let's see. Let's go back here. Let's turn off all these breakpoints. Okay. So test with 2 arguments. Let's go up to mid-dollar again. Okay, we got the string, the start, the length. We get the length of the string as count because we don't know that it's going to be the same. We say we want to take count minus start plus 1 to get to the starting point, the 0-based starting point of our substring. We peel off the right side, we keep, and then we take a prefix out of that, so we get the mid from that. Okay, let's run all tests. Okay, they run pretty quick, don't they? 145 tests. We're getting there. All right, let's check that in. So, make mid-dollar work when third argument is omitted. Alrighty. Yeah, I think we're ready to move on. Not the smoothest, but okay. Let's go back here. What did we say we would do? Well, we got dim. We got to figure out which one to do first. if I guess I'm going to have to do a dim one way or the other, because if it defaults to a dim, it does a dim. So let's do that. We're going to start with one dimension and then work our way up. So I got to find a way to slice, slice it to make it more simple. And I kind of feel like, is that the case here? This is this 8K basic. I mean, can you imagine? I've got, multiple hundreds of lines here. What's our interpreter? 300 lines, maybe 340. They fit that in 8K bytes. It's like, it was cranking. Okay, I'm sure our code is much prettier. Alrighty. So I guess my question was to arrays, and it is funny, these older explanations of the language and stuff. It's all just kind of mixed. Like, how do you turn on your cassette player so you can load your program back in, kind of stuff. All right. That doesn't really explain it. Dim A12. Non-dimension arrays default to 10. I'm not sure they're going to come out and say. Oh, there we go. Okay. Oh no, that's $A sub IJ. Oh, that's different language, different versions of BASIC did different ways to call this. Okay. No, they don't tell you that. I think this BASIC only has one-dimensional arrays. So they've simplified from this one. This one actually had matrix operations, which most of these micro computer basics didn't bother with, at least early on. Let's see. We can find mat is 51. Yeah, so they have matrix operations. You can say mat read, and it reads the whole matrix. Mat print, it prints the whole matrix. You can do matrix arithmetic. I don't know if you can. I don't know if you can only do this, like you can't do expressions, maybe. I'm not sure. Yeah. If mat print A is followed by a 5/8 multi-punch, okay. Yeah, so it's designed for good old Hollerith cards, right? Okay. Basic. Dimensions may not exceed 500, so they allow 500 dimension arrays, but you can only have 1,000 items. So I don't know what that would get you. Some of those dimensions have to be ones. All right. So anyway, the order, I guess let's do it in this order. We kind of want to do both these together, right? I guess we can, this will force us to get the type declarations right. And that'll be a good thing. And these things need to know the types to figure out whether the assignment is valid. So that kind of hangs together. All right. So let's check our lexer. Do we handle dim as a keyword? And I believe we put them. No, we don't. Okay. So we will add a dim keyword. Oh, it's here, but it's not here. Or my alphabetical skills not so good. No, left it out. Dim. Okay. And I'm kind of willing to let that go, and I'm not going to test it separately. I don't think we have a lexer test that runs through every keyword. I figure if I left it off one, I left it off the other, and we're going to have tests on the real thing in a moment on the parser side. So if it didn't work, we'd find out pretty quick. Okay, parser and parser tests. So for arrays, let's see, we got to check parsing, yeah. Test dim. parsing. Okay. And the program is 10 dim a sub 5. Okay. And we expect a parse, but we don't have a dim statement here, so we need one. Okay, so case dim, and it takes integers. I think what we'll do is, even though we're going to support one-dimensional arrays, we can see where things are going, and we'll put the pieces in for multi-dimension support. It's a little bit of look ahead, but hopefully you'll forgive it. Okay, and these actually are integers. I don't think it makes sense to do a float. Yeah, let's make that assumption. Okay, there's no such thing as 4.7 cells or anything like that. Okay, so a dim statement's, oh, it's going to need a name. Okay, if we know the name and the number of dimensions, the values of the dimensions, I guess, because it could be 5, 10, and so on. All right, now the parse we expect back then is, well, we get a print. Let's steal that. It's going to be somewhat like that. And I don't know. Maybe there's a way to take out some of that. Okay, line 10, and the statement is a dim on the variable a, and 5. I got a little friend here this morning. Hi. Yeah, you got some cards. You go play with Grandma. Okay, so where's... That's there. That's line. I guess we need one more. There's line. Okay. Argument passed to call that takes no arguments. Dot dim string int. I think maybe it's just not caught up. Let's hope. I don't think dim's a reserved word. Switch must be exhaustive. Okay. Interpreter, how we're going to define dim for now. Let's ignore the stuff and just return dim NYI. Okay. Parser test and run. Oh. It's not the first time I've messed that up. I don't know, did I mess up the formatting? Okay. All right. Try one more time. Okay, 2 failures. We expected no errors, and we got a known statement, and we got a skip. You know, I want to know where that skip is coming from. Let's figure that out. I think let's find out skip. Remark, yeah, that's a good use of a skip. Can't happen. Well, that's a sign, and we don't care about that one. Oh yeah, this one. Okay. I want to make an error case on this. Okay, we don't have one yet, but I'm going to put one in there on my parse. And maybe this thing needs a string because that will help us. So I'm just improving our error messages for now to try and make, because skip is not a legit thing. Oh yeah. Interpreter on stab. Okay. Just to get us going through here. Okay. So I'm expecting a slightly better message here. Okay. Unrecognized statement is not equal to line 10 parse. Good. All right. So now our parser unrecognized statement. Let's find our statements. Okay. Case def. Well, we got the dim keyword. Okay. And result equals try dim. Okay. New function. Let's put it down here. Function dim throws. All right. So the way we do these is this is recursive descent, and so we have a method for each production rule. I don't think we added a production rule. Let's see, statement goes to dim. Dimension variable left parend, right parend, and inside there is an integer, and then you can repeat comma integer star. There's actually another syntax notation. I'm going to pull it in. Braces mean 0 or more. Okay, so we can repeat integer comma integer as many times as we want, followed by the left parend. Okay. And so our rule is going to map directly to that. So we've consumed the token, get rid of that, skip through the dim, let variable equal, well, actually we want to make sure we have a variable. Let's find a function. I'm trying to look for our predefined or user defined. Okay. Yeah, we basically have this situation. We expect a variable to be present. Okay. So we'll make sure it is. Okay. Let primary equal token. It should be a variable with the name parameter. And then this message, let's see, I would say variable required. And that's a new error message. Oops. I wasn't consistent about these, was I? Okay. All right, so we see dim, we see the variable we should see a left parenthesis. And again, that's almost exactly like this. And then there's a right parenthesis. Okay. And at this point, we expect an integer in here. Okay, so guard case, we'll have the same kind of situation. We've got an integer, let, I guess, size equal the token. Okay, if they don't have that, let's say integer required. All right. Okay, so we skip over dim. We save the variable name as parameter. Let's call it array name. We look for a left parent is required. We pull out the size. If not, we throw a message, and then we pull out the right parent. And at this point, we're ready to make our result. Dim with the array name. And then the list of sizes is just size. Okay. So again, this is very driven from the grammar. And I don't know, this technique, I don't know that it's super well understood, really, but if you can sort of drive your problem into a particular shape and then make your code reflect that shape, it just sort of lines up and works out. And grammars kind of pull that to the max. But you know, introducing this formalism lets you define a mapping into code that just kind of directly handles it. And you can see the same thing, like if you have, what was this called? Michael Jackson, not that Michael Jackson, but the other one, developed his Jackson structured programming. And the idea was you would look at your input stream as if it were a giant regular expression, and look at your output stream as if it were a giant regular expression. And then you can match the parts that happen in the same place in both. And sometimes it's not a perfect match, and that's when the work comes in. But in general, you know, you can kind of drive off the input structure or drive off the output structure, or drive through something that makes them both, you know, both available. And if they don't match, you can like stream stuff to one or the other, and coroutines and different approaches he has. But you know, it really is saying understand the problem structure and then use that formalism to drive some code. Okay, so now all that talk, and I think this test should pass. Cannot assign value of type. Tuple type. Oh, are we returning a type? Oh, we're not returning anything. You know, we should be returning, well, not expression, but parse. All right. Control Y, Command Y. Oh, I'm going to delete all breakpoints, really. Is there one for that? No. Okay. Continue. All right, let's make sure that really runs in a second. Okay, good. Commit that. So we have parse dim statements. Now, what's giving me pause is like we don't tell the type of this thing anywhere. Where's that going to show up? So let's see what interpreter needs. Okay, so interpreter has, let's get down to its body. All right, yeah. Interpreter has, it's got this the globals store, which is basically all our variables, and most variables are global in BASIC except for the ones in function definitions. So this is the predefined functions are already in there, like abs and so on, but it's string to value, and what we need to do is doing a dim statement should put something in the store. It should put like A with some version of the array. And let's look at value. All right, value doesn't know anything about arrays. Now, I don't know if, like, somehow we need to know the size of this thing. We need to know the size and the type. I mean, size or sizes. Well, I don't know if it's an array of type. I mean, in a way, we shouldn't care. Do our tokens know the type? I forget where that gets set. Okay, somewhere down here we parse keywords and names. All right. Oh yeah. Okay, we get the A's through Z's. If it's followed by a $, we add that in. Okay, reserved words, skip word. Keyword. Where's a variable come out? Oh, if answer equals null handle variable, okay. String, digit, program index, token variable. Okay, the variable does not know its type in token land anyway. All right, so maybe maybe this dim should know the type of the array as well. We haven't needed it here. We do in the expressions. Yeah, it's just hard to know what we want to. I mean, in some sense, I would like to say array and not care. Like I could make it depend on the type and know its dimensions and all that stuff. All right, where's interpreter tests? Okay, so let's start testing. Test dim puts, how about knows type and size. All right, so we don't have a print. This one's going to be a little different because we're doing something for the side effect in effect. So we can find one that's a little similar. Well, we could just do the parse thing. Maybe that's. Check parse. I thought I had that. No. Okay. Well, yeah, this is probably closer. Okay. We'll create a program 10 dim A5. Okay. We run the program. And then what we want to assert is interpreter.globals of A is equal to yeah, that's the question, isn't it? What is this? Well, it's an array. I mean, I'm making this up. We want is it an array or an int array? I don't know if I can do the types generally enough. Okay, the type could be .integer or no, .number. The dimensions is 5. And the, let's do 3. 2. Dimension is 2. And the array itself should be 0, 0, 0. Okay, so I think I'm going to do it this way. It should be a array number. Okay, so it should know its dimensions list. It builds in the type because I got to make types. Otherwise, I got to do string ones. Like, how do I make this generic across strings and numbers? I don't think I want to try and do generic enums or anything. Okay, so I'm going to say there's an array of number, array of number, one dimension, max size is 2, and the contents are slot 0, 1, and 2. I really think this should be a 3. I think we want to know the counts. Okay. And this test is going to fail. Okay, yeah, because I don't even have a type for it. Case array of number. And it's ints and floats for the values. Okay. Even if it compiles, it should fail. Okay. Switch bool to float. think I can do it like this. We're going to add a to-do for this one. Case.array upload. Okay, we'll want to add that format. Array of number. And this is interpreter.format. Oh, we did this stuff. Actually, that one was done the day before. Okay. But the to-do, okay, we're doing this. This is kind of the more broad category. Dim is what we're working on. And we need to handle interpreter.format for arrays. Okay, interpreter tests, interpreter globals. Alrighty. So I think what I'm going to do is change my answer. Okay, so it's got a nil back. All right, yeah. The variable was not put anywhere. It wasn't interpreted. All right, I'm going to back up a little bit, and I'm going to change my mind on my parser tests. Okay, I'm going to say this number here should be the count of cells in this dimension. Okay, this test will fail, and we'll just put a +1 in there in parser. Size +1, okay. Because I think in general it's going to be more convenient to know the size, not the size -1. All right. So I think we're to the point with this. We're seeing our, we didn't even find the variable a because nothing put it in the system. So we should handle, interpreter should handle dim. Okay. I guess we can't even see it. Where's the step switch for that? Dim. Okay. Yeah, we would just return junk regardless. Okay, so we need to do some work. And I don't know, I call these handle dim, do dim, or just dim. Do dim. Okay. And this is the name, and this is the dimensions. So we need name, dimensions, and we'll add that down here. I think we need to return a string, right? Yeah. And actually, we'll pass the output in too. We're going to address that one of these days. I really don't like this approach. Like, yeah, well, who put it there, huh? Okay. And we'll just say return output because the statement does nothing. And that'll give us a place to work. Cannot find name. Oh, let. Can I? One more time. Okay, we're back to the failure we expected. All right, let's take a quick break, two or 3 minutes, just long enough to get a drink or whatever, and we'll come back and do some work in this dodim, get the values put in the array, in the globals, and move forward to the work on the subscripts themselves. See you in a couple. Hey, welcome back. All right, we got our failing test. We don't put anything in the array in the globals, and let's change that. So we have the name, we have the dimensions. So let's allocate an array of numbers. Let array equal array of numbers, and the first value is the size, which is dimension sub 0. And the second value is, well, it's an array of size dimension sub 0 pre-filled with all 0.0s. Basic does do that for you. And I know there's a constructor that'll do something like that, so let's go find it. Swift array. Hopefully Apple shows up on this one. Yeah. And I'm sure we can find the initializers down here. Creating an array, repeating element of count. All right, that's what we want. Okay, so dimension sub 0, and it's an array of float, repeating 0.0 for count dimension sub 0. Okay, and let's get the formatting on that right. Okay, so we've got really got this array. It's an array of numbers. It's got the first. It's this dimension size is this first one. I guess we can just pass dimensions in. And then we've got the array of float. All right. Now we want to put globals dot. I guess we can just put it in there. Name equals array. Okay. And this should pass. Oh, so much for that. Okay. Optional. Basic 3, 0. Well, that seems... Let's say we know we're getting one back. I don't think that's going to help anything. It's just a more direct mismatch. Okay, but it gets the optionals out of there. Okay, array of 3, 0.0 is not equal to this. Okay, well that's a function of our value. Okay, and again we're in this equals thing. All right, how do you know two arrays are equal? Well, let's do a value test. Array values equal if dimensions and contents are equal. Okay, and I think we can just use this as a good example. Okay, so we're saying if it's an array of numbers, same dimensions, type equatable. Same dimensions, same values, then they should be equal. All right, and we think this test will fail, but if it passed, we think this bottom test would pass. So we could exit out, but I'm going to just do it the easy way. Okay, and this says, no, those are not equal. All right, let's define it here. Case dot array of number if we compare that to a second array of number, let dimensions 2, let contents 2. Okay. Two array of numbers. Case label switch must have, well, I'm working on it. Okay. All right. So it's going to be true if dimensions 1 equals dimensions 2 and contents 1 equals contents 2. Okay. I think they should be directly comparable already. So yeah. All right. And I think this will make this pass now. Right. All right. So we got one-dimensional arrays declared. Let's see. I'm trying to balance out my time here. What's the good one to do next? One thing I know is going on is the type. We need to enforce types. Okay. So let's add to do just so we make sure we deal with that. Format for arrays. Enforce array types. Okay. Another one is we don't allow redeclarations. So let's deal with that one right now. Okay. May not redeclare variables. So let's we'll muck with the interpreter a slight bit. Let's go ahead and put interpreter.globals sub a equals, and I'll even make it a number, 27. Okay. So we're pretending somebody had already assigned 27 to A, and now we should get an error message. I guess this is the output, and let's assert that the output, and I think it should be this error message basically. Can't redeclare array variable. Okay. And should fail. Okay. So that's something we need to handle in here. All right. Right now we just put this in there, but if let's just say if the name is already existing, if globals dot contains it has entry or something? I don't remember. Well, we can do it this way. We can say if global subname not equal nil, let's return this string. Okay, so if it's already in there, we don't allow it. Okay, good. Let's see. So add interpreter support for dim. Okay. What was I on about? Handle interpreter format, enforce array types. Okay. We haven't dealt with strings yet, but if somebody declares an a dollar, it should be a string. I guess we have to decide maybe it's a parser issue. We got the variable. Well, the variable controls whether it should be of type. Oh no, it doesn't. Oh, I think maybe it should. We maybe need the type, the sort of content type in the dimensions. Okay, who decided? Was that interpreter? Like short-term memory here. Okay. Somebody decided. We decided here to create an array of number. That decision really should be based on the type of the contents of the array. I think the dim statement should tell us that, but I don't know if I want to deal with. I don't want to deal with strings yet. Okay, so don't. Let's get access and putting things in and accessing them done. Oh, yeah, I just am not sure how the best way to do that is. All right, let's look at our parser now. We're going to go back to factor. Up here a little. Yeah. Okay. So right now, a factor could be a left parenthesis, parenthesized expression, could be a number, could be an integer, could be a string, it could be a variable. All right. There's no way to return. There's not like pointers in BASIC or anything like that. So if we see the variable, it's either an array or it's a scalar. So let's go in variable subname and just kind of look around. All right. So a variable, we dig up the token. Notice here we do some type work to say what the type of the variable is. I think the same thing should happen for our arrays. But here you just have variable. Now, if it's a function, predefined function name or a user-defined function name, that's all handled in a different case. This is the case of just any generic variable. Well, in our grammar, let's go back down here, factor, okay, number, blah, 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 factor, variable. Well, we added this, right? We said you could be followed by a left parent and expressions and commas and all that stuff. Well, that's not supported here, right? This thing looks for a variable, skips over it, and then returns the variable. So we will have some work to do to make it support parenthesized expressions. Okay, and I'm going to use that braces style in my grammar. Okay, and I see it up here. All right, we'll get there. I won't try and get them all, but it's okay. So we don't handle this part of things, and I screwed that up. This optional is done by brackets, so let's yeah, okay, so we have a variable. We optionally can follow it with parenthesized expression, repeated comma expressions, and our code doesn't deal with that. So let's handle the case. I don't know, maybe we're going to go the other way. Maybe this case is easier. That's factor. The assignment is going to have this similar issue. All right, let's find assign. Let assign variable assign. Okay, so variable assign has assignment equals expression, but this variable could be followed by array stuff. Okay, so right now we just assign variable. We could assign an array, and yeah, that's going to be a trickier one. I think given we can create it now, I think let's do this one first. Okay, Parser Tests. What's array reference? No, that's not enough. All right. So the parser, right? Let's check parsing well, we're going to parse 10 print a sub 0. Oops. And then it's going to be line. I don't know where it gets this stuff. 10 print we're back in factor land. Expressions. Factor, we got a handle variable. Okay. All right, so we read the variable. If the next thing could be like a plus sign or a new line, but if it's a left parenthesis, then we know we got the array case. Oh, excuse me. All right. So this, I think this is going to be what we call this. It's an array access. Let's start there. We can do better, maybe. Okay. Somebody's going to do an array access. They're going to do name and type. Well, the name is A. The type is float number. Probably not going to recognize these. And the expression, actually expressions, is number 0. Type. Okay. Yeah, we don't have this in our parse. So it's an expression, and I'm saying it's an array access which takes a string variable, a type, and an array of expression. Okay. The array of expression is the dimensions. Okay. Array access, string, type, expressions. Should get some complaints about exhaustive switches. Okay. The type of an array access the name, the type, and don't care is the type. Interpreter. access. Let's just stop. Let's return a string. All right, back to our test. Okay, characters that end, unrecognized statement. Okay, yeah, because we had apparently junk after our variable reference. Okay, so the parse, let's see here, back to parser. Okay, variable. All right, so if the token is not equal to left parent, then this is just a plain old variable, and let's just return it. That's fine. But now we're in a situation where we are accessing this. Okay, so let's well, it's really this, it's this kind of thing again. We're going to require the left parent and something, and the right parent. This is left. Okay, and in our grammar variable, we're gonna get expression. I always do that backwards. And probably the caller doesn't call it yet either. Who calls factor? Oh, he says trifactor. Okay. Factor variable needs a try. Okay. All right, variable. We got the type, the left parent, require left parent. Okay. Let expression equals expression. I want to do a try. Try expression. Did I still get it in the wrong place? No. Okay. Left parent expression. We're skipping the commas for now. Right parent. Okay. And then at the end, we need to return an array access. Okay. So return dot array access. The string is the name. The type we're hard coding now to number. And the list of expressions is expr. Okay. And our test should pass. Oh. Yeah, he should do that. He's marked throws. Okay. Parser tests. Maybe we get them both for free, kind of. Okay. So you print a sub 0. All right. I think we're getting there. Okay. Now we want to deal with the interpreter. And an interpreter. Well, let's capture this. Handle parsing of array references. Okay. Okay. I don't know if our program can we do multi-line programs? I think maybe we can. Let's try it. Okay. Function test array access. Okay, so the program is 10 dim a3 followed by 20 print a sub 0. And we expect it to print a 0. Okay. Dim a3, print a sub 0, expecting 0. Because arrays default to zeros. Okay, array access not defined. Did I? I don't remember putting a breakpoint there, but let's return. Okay, test failed. Array access not defined. All right. This is weird. Oh no. They have a problem called L value versus R value in compilers. And L value says left-hand value and R value is right-hand value. So when you say A equals 7 or A equals B, the B on the right is a reference to the contents of the value, and the A on the left of the equals is a reference to where it's going, not the value itself. And so there's this confusion, and I think we're going to have the same confusion here. The array access, when we're referencing it, we want to look it up. And when we're assigning it, we want to just use, write it instead of read it. Okay. But well, we'll see what happens. Okay. So if this is evaluating an expression, And maybe that's okay because we don't evaluate the left-hand side exactly. We get an array access. It's got a name. It's got a type. And it's got a list of expressions. Okay. And what we want to do is we want to we want to look up the name. Okay. I mean, this is kind of part of it. Okay. Let value equals store name, otherwise type dot default value. Okay, so if the name isn't in the, well, that's not quite correct either. I mean, it certainly returns a 0 if it's not there. But we actually wanted to mention it too. Let's say you have to dim it. So I don't know. I'm going to put a to-do. It's my mechanism of getting through these complicated cases. Otherwise, I don't know. Okay, we did dim. Is that the top? All right, dim. Handle interpreter format. We didn't deal with that. Reverse types, expression, subscripts. Yeah, this is more like that. And the issue is, what if array name not found? Okay. This will get us through. Okay. Now, if the value we get back should be an array. Okay, so let's not worry about this quite yet. Let's just assume it's found. That's why I put the line 2 on the left there. Okay, so we will find it. Now, value, if it's an array, value should be type array of number. Okay, so let's do a guard case array of number. I mean, value should be a value, right? That's right. It should be a, come on, value. Okay. Case, let's see, array, is that's the right one in here, isn't it? Array of number, yeah, okay. So we are expecting an array of number, and it's got those fields, dimensions, and values. And if we don't do that, we're just going to blow out for now. Okay, so you can't do that. I'm just getting through the case here. All right, so now we know variable binding in a condition requires an initializer. Oh, equals value. Okay, so we're going to pull out the value. We're going to make sure it's an array, and then we're going to I think we'll not worry about the dimensions. No, we do have to worry about that too. we need to evaluate the expression.
I'll be right back.
Okay. Evaluate expert with expers. Okay, we'll just evaluate expert sub 0. We only support 1 right now. With the globals. Do we pass in a store? Yeah, we should use store. Okay, so we got a sub something. We're gonna evaluate that something. Now we got maybe this is an index. Okay, and we want to check. Well, check inbounds. All right, so let's put this in here too. Bounds check. Okay. We want to say return values sub index. Is that all we got to do? All right. Array float subsequence to return type value. But our values are we need to wrap it in our type. Okay, dot number of values subindex. Okay, because the array contains float. Values. Okay. The values are the array of contents. So I think we want to get to contents. Can I convert value of type value to expected return type int? Now evaluate. Is that right? Okay, let's look at array of number. It takes ints and floats. Okay, so this should be a float coming back, and we're going to wrap it. And it's still not happy. Can I convert? Oh, index, yes. Dot as float. And then we'll have to use an int of index down here. Okay. Is that better? Yeah. Type was never used. Interesting. Okay. Dimensions was never used because we're just assuming there's one dimension. We're not looking at the bounds. And let's see this test. Interpreter tests. Let's try this again. All right. That passed. That's something. I guess the thing is that all we can do right now is put zeros in, so it's always 0. So if we do the assignment one, then we'll get the chance to make a better test. All right, and I think that is the assign is going to have to be the next then. Yeah. Okay. Yeah. So we kind of covered this case. If the variables, if we come in to do assign and the thing on the left is not a variable, then um, we've we've attempted to assign, I don't know what. We said, I mean, I don't think it can't even really happen, except now it can. Okay, so let's I guess our parser is not up to the job yet, so let's deal with that. Okay, so here we do array access, and that's fine, but that was in the context. Well, no. I think that's used by assign as well. Let's see. Try assign. Okay. He checks to make sure the next token is a variable. And then he parses it as a variable. Okay. So I think that try variable name could be coming back as an array access. All right. So I think we get an assign statement with the variable, which includes the array access one. Okay. I think we're ready to interpret. It won't work, but we're ready to try. Okay, so let's let line 20 be. Let's switch to the other kind. Um, assignment to array. All right, so we create an array, we set the value of slot 1, and then we print slot 1, and we expect it to be filled in. I'm gonna run that, and it should fail, I think, on line 20. Okay, I'm glad it failed. Improper rel value. All right. Let's find that. Improper L value. Okay. And I think that 0 is probably, yeah, so that's probably, the 0 is this thing being printed anyway. Let's at least do that to clean that up a little. Improper L value not equal to 17. Okay, so it does not get assigned case variable. Yeah, so right away, we come in now. It's an array access. That's why it's not a variable. I don't know how to do. I guess I got to do a switch statement. switch L value I'm just moving the stuff around here. Name equal okay, so this is rewriting that from the guard case to just the case. Okay. And should fail the same way because it shouldn't change anything. Actually, let's run all tests. One failure. Good. Okay. So if it's a variable, then that's fine. Otherwise, it should be an array access. And this is the name. The type, I don't know if we need it. And the experts. Okay, if we see an array access, okay, what are we going to do? Well, we're going to have to evaluate the expressions. So let's do expr sub 0. Okay. We certainly need, well, this. Yeah, this structure is more complicated, isn't it? I think I can just assign it directly. We're going to hard code that assumption for now. Look up the array. Yeah, let's do this way. Array of numbers, dimensions, and values is equal to global name, else I don't know. I just want to get some error and get through this. If you look up the dimensions and values, it's not an array of number. Indexed non-array. Okay, just to get through there. All right. So now we know the index. As float. Okay. And we know the dimensions and values. All right. So now we want to say, I don't know. I think I'm afraid if I change values, I don't know what happens. Okay, the expression here is the R value. Let's even use that language. this. L value, R value. Okay. All right. And I think this is where cannot assign values to the let constant. Oh, yeah, we're getting this back. This is where Swift's got this copy on right thing with arrays. That arrays are really structs, which are like read-only values, and Swift has a lot of kind of hidden mechanism to make it so that you can pretend they're pure read-only kind of things, but if you write them, a new copy gets created. But behind the scenes, the new copy is not a full copy. It's not as expensive as that sounds. I don't know. I may have to assign it. Updated values at position equals the R value expression. Sorry, let's make sure we got the types right. There should be a float. Okay. Int subindex should be fine. Value of type expression. What's the type of R value? Expression. Well, he's a float too. Because that's the kind of array we got. Okay, so now I think this is where we have to do this kind of thing. And I don't know, I may be creating extra copies or something. It's hard to see. Dimensions, right? And updated values. Float as the member number. Updated values. Oh no, this is a float. Sorry, R value. Wait, we want value. Okay, so we're going to update the value in that values array, set this value, and then back in the globals, we're going to update the array to point to the new value. I feel like I'm doing something way off. And return the output. I mean, I feel like I'm making copies. This implicitly copies, but this is this copy on write thing, so it only updates the one value. But this, to me, looks like we're creating a new copy. Well, let's see if it passes and then worry about it. Yeah. Okay. Well, I'm happy about that. I mean, it works. I think there's maybe a performance issue that we should probably deal with at some point, but that's okay. All right, we've gone a while again. Let's take just a couple minute break, and I think, well, we'll see what we got to do on some to-dos. Interpreter format. I guess we got to deal with string arrays and multi-dimensional arrays. Okay, so I'll see you in a couple minutes. All right, welcome back. Okay, so let's see. We've dealt with expressions. We need to run all our tests, don't we? Okay, let's do that. Okay, great. And commit. Handle reading and writing of subscripted expressions. Okay, let's see. So, what if an array name is not found? Well, that's less of a problem than a conflict when we go to write it. Let's see, where did we handle that? Do dim. Okay, that's sort of okay. Yeah, so we said if you try and access an array, read or write, and it doesn't exist yet, then it should act as if you had already declared dim the array with 10. Okay, and yeah, so and that's really in each dimension, but we haven't dealt with the multiple dimensions. Okay, so I think okay, this is the do assign. Let's deal with that one first. The array name is not found. Okay, where are we? Array access let name. Well, here's global subname. Okay. If well, it's really a question of lookup, isn't it? Okay, so the case we want to deal with, array assignment to array non-array variable. Okay, so if we say a equals 3 and then a sub 1 equals 17, that should fail. Now this is, I think we're going to get this. No, we're not. Oh, well, we didn't assert that it failed, so let's, we don't expect 17. We really expect, I don't know what the message will be, but it might be this, indexed non-array. Well, no, I don't expect that. Oh, do I? Yeah. So if the I kind of expect it even now. A sub 3, and we say check that it's an array of numbers. Well, it shouldn't be at this point, should it? Okay, let's watch this one fail. Try to subscript non-array. That's more like the message we want. Index non-array. Okay. I guess all these need new lines. Let's find subscript non-array. Okay, this is evaluate. Oh, that was this line. Okay, yeah, we don't care about that line. Let's run this again. Yeah, okay, so that one is already okay. If you've declared the variable as a number, I mean, you've instantiated into being a number, and then you try and use it as an array, you get this message. That's probably, oh shit, index non-array. The message could be better, right? So we're saying, I think we're saying attempted to use non-array as an array is probably the right message. Now, the next one is if the name doesn't look up. All right. Yeah, this is a real change. This is array without dim defaults to size 10. Okay, so we don't actually have a way to look up the count of an array. Oddly. All right. How can we tell it's there? I guess we need to do more like our other interpreter test. This one. Okay, so if the program is print a sub 2. Well, let's do it this way. A sub 2 equals 3. The interpreter. Okay, I guess we're going to look at the type at the end. Assert output. I don't think there's a problem with the output. We want to go in the variables. So let's store equal. Well, let's just talk about interpreter dot globals sub a Okay. What should that be back as? Well, it should be, it's a value, right? So it's array of numbers. This max count should be 11. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we should get that in the interpreter globals, and one more close, and we don't look at the output. Okay, so we're checking that assigning to an array implicitly dimensions the array. Okay, yeah, that's good. Interpreter, okay. Oh, let me just delete this. We pulled that out earlier. 367. Okay, so this is really if it doesn't exist, so this exclamation point. So if global subname is nil, then we have to do like we did for dim, right? So do dim output. Well, it's this stuff. And I'm not sure how I want to clean this up. So I'm just going to copy it in, get green, and then see what we can do. Okay, so if the global name is not nil, is equal to nil, that means the array is not found. Dimensions is going to be 11. And 11. Okay. So if the array is not, if the name is not found, we're going to create an array value with one dimension 11, because 0 through 10, and then an array of float repeating 11 copies of 0. So we initialize it. And we're going to write that to the globals, and then we'll check, and this exclamation point is now legit. If it's already there, which if we just created it, it will be. So we'll pull it back out and look at it. If it was already a variable, then it wasn't nil. So we're coming into this case where it's not going to match. Okay. So I think that should be good. So much for that theory. All right, what do we got? Ooh, oh, right. Yeah, it should be 3 at this point. So 0, 1, 2. Okay, but it did get created with the right number of stuff. Okay. All right, so that handles the assignment side, but it also could be on the right-hand side. I think that's evaluate, right? Where's evaluate? Oh, yeah, let's do that. If we're not looking at it. Okay. I don't know why it did 2. Just another bug in. Okay. All right, here's evaluate. All right. So evaluate for array access. Okay. We look up the name. Right. It's a very similar bit of code. Okay, if the name comes up nil, then it's not being used. Okay. We're going to want this same bit of code. And globals is the right place. All right, because it implicitly creates a global declaration of this thing. If the name is nil, then we create the value with that, and globals gets the array. A little weird. I mean, this. You can't pass the array name as an argument, so I don't think it's going to matter that it's store versus globals. Okay, let's see how this. Oh, shoot. Well, let me comment this out for a brief moment. Put the test in first. This is array assignment. Print a sub 2. Globals, this should be a 0 now. Okay, the big thing is we have this with all these values. We'll quickly implement that and check it. Oh, still not there. Now, this is where I think it has to look up in globals. Here. I was hoping it wouldn't care, but again, this copy thing. Because array references are always in the global space. They're never arguments. So I think that's why. Yeah. Yeah, you got to be careful with these namespaces for sure. Alrighty. Run tests. Okay, to do. What if array name not found? All right, we've dealt with that. Bounds check. Well, okay. Yeah, let's make a test. Well, this is more of a check program. Let's use that. I don't know why this keeps reformatting so funny. Okay, since this thing dimensions automatically to 0 through 10, if we say a sub 11 equals 17, we should get an error. And I guess maybe we can combine this. A sub -1 equals 42 should also be an error. Okay, so we're expecting 2 messages. I don't know, those are kind of wimpy messages, but and since we're clearly not checking, okay, index out of range. Let's see. Let's find the right place. Do assign. Oh, I wanted to do the other side. Let's do this. It's a legit test the other way too, but I'm going to do the right-hand side first. Okay. Yeah, blows up right below the line where we said we should check if it's in bounds. Good. If index less than 0 or index is greater than well, now we wish we had dimensions, don't we? Let dimensions suppose I should use the string I used here or access out of bounds. And this is a string. Oh no, it's just what are we doing? We're evaluating. It's really an error. We did add that in. Oops. Value has no member error. Okay. Value. Oh, okay. I guess we did something in the parser this morning. Maybe you should do that here too. Let's do this here. We don't need it here then. Try again. Whoa. Okay. What's going on? Oops. Equal. All right. And I think we'll just go ahead and write the test for the next one and have that ready for next time. Okay. Bounds check array right. And this is the one we had before. A11 equals 5. Okay, and we expect that same message. Okay, so we'll let that run. It should fail, and we'll pick up there next time, which is Monday. So Monday, let's see, 4th, 5th, 6th of June at 10 a.m. Eastern Time till 12:30 p.m. And that's the same as 3 to 5:30 p.m. UTC. We will we'll get this bounds check working, and then I think it's probably a good time to work on multidimensional arrays. Yeah, we'll do that. I think we've got the pieces there with the lists we used everywhere, but we don't really support them yet. So that'll be fun. And thanks for joining me today, and I hope I can see you in the future. Bye-bye.